Welcome to this explainer. Listen, if you're a CTO, an engineering leader, or really anyone architecting modern software right now, you already know the truth. Managing passwords is an absolute liability. But let's actually quantify that pain for a second. We're talking about the sheer exhausting cost of endless password-related IT support tickets just systematically draining your help desk budget. We're talking about that deep, lingering anxiety of guarding massive databases of password hashes, knowing full well that a single unpatched vulnerability could literally put your entire user base at risk. Passwords, they're a massive attack surface. They're a constant source of friction for your users, and frankly, a black hole for your security resources. So today, we're tearing down a clean, enterprise-grade shift away from that legacy model. We're going to examine VeriLink. It's an identity provider that handles authentication entirely on your user's behalf, effectively eliminating passwords from the equation. And honestly, the best part? It does all of this while drastically slashing your attack surface and completely avoiding vendor lock-in. Okay, let's dive into the agenda for this structured technical teardown. First, we'll define the new identity layer, then look at the standard OIDC architecture. After that, we'll walk right through the passwordless auth flow, examine device-bound magic links, cover the zero credential attack surface, and wrap it all up with centralized token governance.
Section 1. The new identity layer. Offloading identity entirely.
So in modern architecture, identity really shouldn't be some bolt-on feature. It definitely shouldn't be an afterthought that's just tangled up in your core application logic. It needs to be a dedicated, completely offloaded layer. Your platform essentially trusts VeriLink to act on the user's behalf. It becomes the definitive system responsible for verifying exactly who a user is and issuing the tokens that confirm that identity. Really, think of VeriLink like a password manager, but for the passwordless era. That right there is the core mental model you need to adopt to grasp the shift. Because just as a legacy password manager centralizes and governs complex passwords so the user doesn't have to, VeriLink centralizes, stores, and governs OpenID Connect tokens. It isn't just a simple login utility, It's a highly robust, centralized manager of identity across your entire digital infrastructure.
Section 2. Standard OIDC architecture. Open standards. Zero lock-in.
Now, the absolutely crucial point here is that this offloaded identity layer, it's built on a universal, open standard. And let's be real, for engineering executives, avoiding vendor lock-in is a massive priority when you're choosing an infrastructure partner. I mean, you've probably lived through the absolute operational nightmare of having to rip out custom, proprietary SDKs when migrating systems. It is a heavy, incredibly expensive lift that embeds a specific vendor's code deep into your application stack. Traditional proprietary identity providers, well, they often force you down that exact path, creating some really heavy vendor lock-in. VeriLink takes the exact opposite approach. It uses standard OpenID Connect endpoints, specifically the standard /OAuth, /authorize, and /OAuth /token paths. What this does is create a true drop-in identity provider. If your platform speaks standard OIDC, boom, you seamlessly connect to VeriLink. Universal compatibility, zero proprietary SDKs required. Plus, relying on the standard approach paves the way for advanced security extensions like PKCE compatibility, which we're actually going to unpack right now.
Section 3. The passwordless auth flow. The mechanics of token issuance.
Okay, we've established what this architecture is. Now let's look at exactly how it works under the hood. Because in security, there's absolutely no room for magic hand-waving, right? We need to see the exact chronological handshake between your app and the identity provider. Let's walk through how this builds across 4 very precise steps. Step 1. Your app initiates the authorization request to VeriLink using standard OpenID Connect protocols. And crucially, this is where OIDC with PKC, that's proof key for code exchange, comes into play. Your application generates a cryptographic secret and sends a hash of it right along with that initial request. Step 2. VeriLink takes over the flow entirely, sending the user a secure, device-bound magic link. VeriLink is now verifying the user's identity on your platform's behalf without exposing any credentials whatsoever. Then, Step 3. Once verified, VeriLink issues OpenID Connect tokens back to your platform. But because we are utilizing PKC, your application actually has to provide that original cryptographic secret to exchange the authorization code for the actual tokens. This makes the flow absolutely ironclad, especially for mobile and single-page apps, because it mathematically prevents authorization code interception by malicious actors. And finally, Step 4. The user's session begins, and VeriLink centrally manages and governs those tokens. It's just a seamless, mathematically verified flow straight from the user's device to your secure portal.
Section 4. Device-bound magic links.
eradicating replay attacks. Now, you might be wondering about the specific security of that link centering step 2. Magic links are for sure incredibly user-friendly, but a standard, naive magic link can actually be vulnerable if it's intercepted in transit or forwarded. Well, VeriLink solves this by strictly binding the link directly to the user's hardware and network context. So a device-bound magic link is a single-use, short-lived authentication link strictly tied to a user's specific device and IP address. The very moment it's consumed, it is instantly invalid. But how does this actually work technically? CTOs ask this all the time. What prevents a bad actor from just copying a magic link from a compromised email inbox and pasting it into their own browser? The answer is context anchoring. When the user requests access, VeriLink fingerprints the originating environment. When the link is later clicked, it checks to ensure that the consumption environment perfectly matches the request environment. If the IP address differs, or if the hardware profile shifts, say someone moves from a mobile device to a desktop browser halfway across the world, the link simply fails to authenticate. By anchoring the authentication specifically to the hardware and network context that requested it and enforcing strict single-use limits, you completely neutralize replay attacks. An intercepted link is utterly useless to an attacker. No way around it.
Section 5. Zero credential attack surface. Eliminating the target.
Let's zoom out a bit and look at the macro security posture of your organization. This is where the absolute enterprise security benefits of completely removing passwords from your infrastructure become powerfully, undeniably clear. Think about the constant looming threat of credential stuffing attacks. You know the drill. Automated botnets hammering your login endpoints with millions of leaked passwords from other internet breaches. It's the kind of scenario that keeps security teams awake at night. But look at what literally no longer exists in a VeriLink architecture. There are no stored passwords anywhere. None. There are no password hashes sitting in a database just waiting for a zero-day exploit to expose them to offline cracking. There are no convoluted, highly insecure password reset flows for a clever social engineer to hijack. Because there are quite literally no passwords in the system, the entire attack surface that credential stuffing relies on, it simply ceases to exist. Just imagine the sheer operational relief of systematically deleting your password databases. The most secure data in the world is the data you do not possess. You simply cannot breach what you do not store.
Section 6. Centralized token governance. One place to govern and revoke.
Of course, getting the user authenticated is really only half the battle. Post-authentication lifecycle management, that is a critical concern for enterprise governance, compliance, and auditing. Because VeriLink acts as your dedicated identity provider, all that security enforcement happens centrally, right at the IDP layer. You're no longer scattering authorization logic, session timeouts, and token validation across dozens of individual apps, microservices, or legacy systems. Instead, you have a single, unified pane of glass. You can revoke sessions, rotate tokens, and audit user activity globally. For an engineering leader dealing with complex compliance frameworks, think SOC 2 or ISO 27001, this kind of centralized auditing is a total game changer. It takes what is normally a massive compliance nightmare, tracking access logs across deeply fragmented systems, and turns it into a simple, verifiable checklist item. You have absolute real-time control over active sessions, all from one centralized location.
Before we wrap up, I want to briefly touch on how frictionless this integration is from a business and financial perspective. 30 days. VeriLink's enterprise model bills per active user on a 30-day cycle. Ultimately, this is fundamentally about predictable OpEx. You see, legacy authentication providers often create this completely perverse incentive structure where better security, meaning more frequent re-authentication events or step-up challenges, actually costs you more money per API call. VeriLink removes that penalty entirely. It doesn't penalize you for having secure, frequent authentication events. You aren't charged per login. This means you can aggressively enforce strict security policies and incredibly short session timeouts without having to constantly worry about unpredictable variable microtransaction costs just ballooning your monthly operational budget.
So to wrap this up, I want to leave you with a provocative thought to challenge your current architecture. Are you still managing a credential attack surface that simply doesn't need to exist? Seriously, if you are storing passwords, if you're hashing credentials, or dedicating highly valuable engineering cycles to building complex reset flows, you are taking on massive liability for absolutely no technical reason. By embracing standard OIDC with PKCE and device-bound links, you can achieve absolute zero credential exposure. Take a moment today to really audit your own attack surface and ask yourself why those legacy passwords are still sitting there. Thank you so much for joining me for this explainer. I hope it provided a clear, actionable perspective on what modern, passwordless identity management truly looks like.